Alright, so in this video, we're going to be talking about some uses of the cross product, okay? So the first thing that we're going to be talking about is that the vector A cross B, okay, so basically, the vector product or the cross product, wherever you want to say, is orthogonal to both vector A and vector B, okay? And this is going to really come in play later, okay? This is a big thing. So what this is saying is that your cross product, okay, that vector that you get, is going to be at a right angle to both vector A and vector B, okay? But that can mean that it points one of two directions, right? And A and B are on this plane, this whiteboard, okay? Well, that'll be our plane here. And that means that if the cross product is going to be orthogonal to both those vectors, that it can either point out of the board or into the board, okay? So how do we know which direction that it points? Well, we use the screwdriver method. You can use the right-hand rule if you want. You can use the right-hand rule, so if you go from A to B, okay, you see that my thumb points outwards, okay? So your fingers go from the starting vector, which is A, to B, okay? And you see how my thumb points outward. So we know that the vector is going to point out this way. However, I kind of like to think about it as a screwdriver. Okay, this is a method that I like. If you're turning a screwdriver from vector A to vector B, you're going to loosen up that screw, right? You're turning it lefty-loosey, okay? So you're going to loosen up that screw and it's going to come out. So that means that you're going to be coming out of the board. Okay, that's the way I like to think about it. It's just easier. But anyways, yeah, that is something big. So I'm actually going to show you some proof of this real quick, that A cross B is orthogonal to A, the vector A. And the same thing is going to happen for vector B here, and you can double check if you would like. But I'll just at least show you that these two things are perpendicular to each other. They're orthogonal. Okay. Now, what does it mean if the dot product is 0? Well, that means that the two vectors are orthogonal, so that's why we're taking the dot product here. Okay, now A cross B. In the explanation video, we figured out, for cross product that is, that A cross B equals this vector right here. Okay, it equals A2B3 minus A3B2, comma, A3B1 minus A1B3, comma, A1B2 minus A2B1. And now we're going to dot that with vector A, which is just going to be A1, A2, A3. All right, so when we dot these two things, what we end up getting is we get A1, A2, B3 minus A1, A3, B2. And that's going to be plus A2, A3, B1 minus A1, B3, B2. Actually, no, sorry. It's going to be A1, A2, B3. And then there's going to be a plus here, and we're going to have A1, A3, B2 minus A2, A3, B1. All right? So that's going to be the dot product of these two vectors. Okay? Now, what you see here is that, well, we have an A1, A2, B3 here. And can we find another one? Well, yeah, we have an A1, A2, B3 here, but now it's negative. So this gets canceled out with this. How about here? We have an A1, A3, B2, and that's negative. And we have a positive A1, A3, B2 here, so these go away. Okay? And then, lastly, we have an A2, A3, B1, and that's going to get canceled out with a negative A2, A3, B1. So this whole thing is equal to 0. Okay? And that means that they are going to be orthogonal. Okay, these two vectors are orthogonal. So the cross product can also help us find the angle between two vectors. Okay, if theta is the angle between vector A and vector B, then, well, in this formula it looks a lot like it did with a dot product, except for now we have the magnitude of A times the magnitude of B times sine theta, rather than with dot product it was cosine theta, and over here we had A dot B rather than the magnitude of A cross B. Okay, So if you divide the magnitude of A and the magnitude of B on both sides, what you get is that sine theta equals the magnitude of A cross B over the magnitude of A times the magnitude of B. Okay, now, what we also did when we had the dot product formula, which had the cosine theta here, is we made cosine theta, we made that 0. Okay, and what that said was, well, since to make that cosine theta 0, we had to plug in theta equals pi over 2. Okay, so what that meant is if we plugged in pi over 2, that if our dot product was 0, okay, if our dot product was 0, that meant that, well, the angle is pi over 2. Okay, we have two vectors that are perpendicular. So now we're going to be doing the same thing, but with cross product. We have a sine theta here, okay, and we're going to be making that 0. How do we make sine theta 0? Well, we have to plug in a 0 for theta. Okay, sine of 0 equals 0. Okay, and if that equals the magnitude of A cross B over the magnitude of A times the magnitude of B, well, we can multiply this magnitude of A and the magnitude of B over here, and then it just goes away. So we get that this is equal to the magnitude of A cross B. Okay, so real quick here, we had to plug in a 0 and not a pi over 2 into that trig function. Okay, so that's the angle between the two vectors. So when we get our cross product to be 0, the two vectors are not perpendicular, but they're parallel, because the angle between them is 0. All right, so I'll write that down. So to kind of conclude on both the cross product and the dot product, when the magnitude of A cross B equals 0, the two vectors are parallel, but when the dot product equals 0, the two vectors are orthogonal, okay, or perpendicular, whatever you want to say. Okay, so, and also, by the way, if this is confusing you, why I have a magnitude here and not a magnitude here, well, that's because the output, our cross product, is a vector, okay, so we need to find the magnitude of that, and for A dot B, well, your output is a scalar, so you don't need to find the magnitude, okay, your dot product is a magnitude, okay, so you don't need to find the magnitude of it. All right, so the last thing that we're going to go over for uses of the cross product is that the length of the cross product, A cross B, okay, so that's saying the magnitude of A cross B, is equal to the area of the parallelogram made with vectors A and B. How do you make a parallelogram with vectors A and B? Well, here's vector A, here's vector B, okay? If you put a vector A, okay, so this is kind of like picturing vector A, you connect it to vector B, and you connect vector B onto the end of vector A, and you make a parallelogram. So the area of a parallelogram is base times height, okay? And, well, our base is going to be the magnitude of vector A. Why the magnitude? Well, we're not going to put in a vector, okay? Whenever you've done a base times height or any area formula or anything like that, you're not putting in the vector 2, 3. You're putting in a scalar, like 6 or 7, whatever. Okay? So that's our base. What about our height? Well, our height is this distance right here, okay? And that's the same thing as saying the magnitude of B times sine theta. Okay? Well, how did I get that if you're not 100% with me here? Well, sine theta equals the opposite side over the adjacent side, okay? And, well, the opposite side, we're not going to know yet, so that's going to be x, okay? Let's say we don't know what this is. And the hypotenuse is the magnitude of vector B. Again, we're dealing with scalars here, so we're going to take the magnitude of that vector. Now, remember what this is equal to. This is equal to sine theta, okay? And I know that's over there, but I want to have these things right next to each other, okay? So you see how I got this? I just use opposite over hypotenuse. Now, if I multiply by the magnitude of B on both sides, you see that I get that x, our opposite side, okay, that's what x is standing for here, is equal to the magnitude of B times sine theta. All right, so just a little bit of SOHCAHTOA usage. Actually, I'm going to leave that there. Yeah, let's keep that there. So you see now that our height is the magnitude of B times sine theta, And what is the magnitude of A times the magnitude of B sine theta equal to? Well, that's equal to the cross product. So the area is equal to the magnitude of A cross B. Okay? And for a triangle, if this is BH over 2, well then you're going to have the area equaling the magnitude of A cross B over 2. Okay, so these are two things that you may be asked. Okay, we're going to be doing some examples with this. You may be asked, okay, find the area of the parallelogram made with the vectors A and B. You take the cross product, you get your answer. If it's a triangle or something like that, well, then all you got to do is find the cross product and divide it by 2. Okay, so that's basically it. That's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space in the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.